Hello everyone, and thank you for joining today's webinar. My name is Yang Li, and I'm your host and moderator during this webinar. I'm very happy to welcome our guest, Marco Forlingieri, who is the modeling and simulation manager at Airbus Group. Marco has lots of experiences in model-based systems engineering and also product engineering. We're happy to invite Marco to be here to share with us his thoughts on the model-based development of product lines at Airbus. Before we jump into the topic, I would like to shortly mention that you can find all of our upcoming webcasts on our website. All webcasts are recorded and uploaded to the Pure System YouTube channel. So if you have any questions, you can post them at any time in the chat system. Only our webcast team will be able to see your questions. And we will collect your questions and answer them in a Q&A session at the end of this webcast. Okay, so welcome again, Marco. So it's nice to have you here. Would you like to say hello to our audiences?
Yes, of course. So thank you, everybody. So I'm really happy to be here today and to share a bit about the topic of MB-PLE, so model-based product line engineering, general product line engineering, variant management at Airbus. So I'm really happy to be here, and I hope it's also the same for you.
Okay, thank you, Marco. So today, we will talk about the variability management at Airbus. So you are an expert in model-based systems in engineering and also product line engineering. And now you are leading the topic of model-based product line engineering at Airbus. We aligned with you previously, right? We collected some questions. So my first question is about, of course, the motivation part. So what is the motivation for Airbus to develop the product lines and handle the variability in a systematic way?
Yes, so this is a very good question and really important, actually. And so for us, it's really important, the topic of variability, because as you can imagine, we have different aircraft, different families of aircraft, and we are a big organization, and we have to deal with that. Okay, we have to deal with the variability. So that's a key question for us. Maybe it would be useful I have prepared a couple of slides. I will use them to help the answer actually of this question, to help answering this question. The main motivation, I would say, is that Airbus, it's moving in the last years, started to move from a product-based to product line-based development. So you can see here, this is an example, a simplification of the current, and I would say old, because we are changing this, product-based development. You can see some phases of the development, like from feasibility to studies and of the new airplane, up to the design, to the integration, and so the flight testing, and so on, up to the final delivery of the airplane. So this is basically the old way, and the existing still way of developing the aircraft. But one of the biggest motivation is that we want to move the activities more on the left side, so more on the off-cycle side. And that's one of the key things that you do when you want to start a product line. In order to do that, we envision a change in this product development plan. So we are going now, no, we don't have anymore one phase, single phase. We will have two phases. One is the out of cycle, where we might develop and baseline the so-called product line and all those assets we will see today that we would like to reuse within the product line. And then the in-cycle, where we do the development of the part of the customization plus the addendum, so the additional things, the options that are requested specifically for the customer. And so that's one of the motivation is really that in order to be on time with the delivery, in order to sustain the competition, and of course, in order to be able to produce programs, evolution of the new aircraft programs in a reasonable time, with always a high level of quality, we really need to envision a new way of working, a new way of producing the aircraft. So this is for sure one of the main motivation. But and this can also be summarized again. I'm trying to repeat a bit the same concept, but with another with some other words, I would say. So to go more in the detail, because before we just saw the high level part, what we try to do, it's really to go to this product engineering to product line engineering approach. So first of all, we had already family of products. So it's not that in the past we didn't have a family of products. If you look at the A320 family or the A350 families, so they are families of products. And even if you go into other divisions like helicopters, you will have also family of helicopter products. However, the type of reuse, the strategy in reuse that we undertook until now, it was more, let's say, reuse by experience or reuse by because we had a chance to reuse. It was more a type of opportunistic reuse, if we can call it this way. So where we have a product developed, we see that there are some things that went well. We want to bring it to the next program. And that's why we just, in parentheses, we copy and paste the assets between the product and we reuse them. Which is the problem? The problem is that we don't have a unique source of truth, unique source of information. It will be difficult to manage the changes, to understand what varies from one version to the other. So we start to have a lot of problems, and we will lose also the understanding of our product. We will lose also the cost of the eventual change that we have to our product. So that's why we envision this product engineering based approach, where we develop common assets on the left side, and we reuse them. But we reuse them with a systematic reuse. So we manage the reuse of common and variable assets in a systematic way. We will see with the help of product line engineering approach. And in this case, we have a unique source of information. So we know what we are using. We know we do it in a consistent way, in a formal way, and we can better control that. So why we do that? Okay, so why is not that from one day to another we decided to move to a product line based approach. The challenges are really probably well known from the benefits are well known from most of you, but still I would like to quickly go through them. Of course, as I said, we can better manage the reuse of assets, so of what we produced in terms of design assets, but also in terms of suppliers assets and qualification assets. So it's much better the reuse of it at different levels, from system to subsystem component. We aim at decreasing time to market, because it's true that in the beginning we will have a penalty in the development, so a lead penalty in the development of the first or the product line of the out of cycle part. But the idea is to along the time to reuse and reduce break even and reduce this initial investment and start to have gain on top of that. So that's why we want to consequently reduce the development cost. We are talking both about non-recurring and recurring cost through economies of scale, for example, with partnership with key suppliers, buying more quantities and having more standardized parts and reducing the cost of changes also on their side. The product risk, we focus on the new things, but we know that what is certified, the part of the product line that is certified, what is stable, it doesn't have risk, because we carry over this part for a long time, so we have much less risk on something that we develop just for the first time. And then, of course, cost estimation. If we have a change driven, we can easily, due to the traceability, due to the that we have, we can easily understand what happens if we change a feature to our architecture, which is the impact on the different level and so on. We can better use the people, so we'll not have people doing the same things within the different programs, but we will optimize with a new organization the reuse of the people and on key positions. And of course, the idea is also to be able to standardize the interfaces to enable collaboration with suppliers and development with suppliers, stable interfaces. And also there is the aspect that is not is something we need to remember, that we can better exchange lessons learned, because the information of what we reuse is shown, and people can see what is reused and why it is reused. The information is not just in the head of the experts. And finally, we do all this for one specific reason. So we want to be able to maintain the market presence as probably first airplane manufacturer in the world. So this is for sure. So we do that in the end for that. And of course, we don't have to forget that we need to consider initial investment. Okay, so when we do all this thinking and this assessment, initial investment, it's important, and we need to consider such initial investment when we develop the product line. Okay, so this is basically some of the motivation that I have, and then maybe I can mention also the fact that this transformation, we do it within a program in Airbus called DDMS, so Digital Design, Manufacturing and Services. It's a transformation program that will last at least until 2025. And we are, let's say, developing a new way of working in different functions. So not only engineering, but also manufacturing and also services. So we really are envisioning a new way to develop and to offer our product to our customers, and to manufacture them as well, of course, as I said. And product line is really a key pillar of it. So product line is really one of the key pillar of this transformation program. I hope I answered more or less the question. Sorry if I spoke too much, but it was a big question.
Yeah, sure, I understand. Yeah, thanks, Marco. Yeah, so I can see program engineering is a modern way to reuse your assets and to reduce the development costs and so on. But I think you might meet some challenges when moving to PLE, especially in such a big company at Airbus. Would you like to share with us what are the challenges of introducing variant management or PLE into Airbus? Or let's say, what are the challenges of variant management in particular to Airbus?
Yes, so I will start with this simplification that I make when I try to explain the challenges of implementing product line engineering and variant management. So, and this probably it's not let's say exhaustive. So it means that there are also other ones, but these are for me the keys. First, within DDMS, we aim, as I said, not just at transforming the way of working of the way we engineer the aircraft, but also the way we offer the services to our customers and the way we manufacture it. Okay, so this means that the variability that we have is not just at the product level, okay, at the aircraft level, but is also at the industrial system level and at the services, because we'll have different packaging of services. Service is more seen as an extended product, and we have the variability in the different manufacturing gigs and tools, processes, industrial system that we use. So it means that we have to consider the variability not just at the product aircraft level, but also as a system of systems, okay, considering the services and the industrial systems, okay? So this is one of the challenges. It is not easy because your scope is bigger, okay? The division, the people you have to involve are much bigger than the usual engineering department. The second challenge that I have, we have, not me, is, as I showed you before, the product development plan of Airbus, a simplification of what I showed before, of course. We have variability at different phases. So the variability that I have during the feasibility phase of a program is not the variability that I have during the integration, design, integration, and delivery of the last phase of delivery, the last customization before delivering the aircraft. So we need to consider which inputs of variability we need at which specific stage, how our variability evolves, and how we can be able to support engineers at all the phases, okay? So if an engineer tomorrow comes, I need to develop a new program, and this is the case, I will have a first phase where we need to evaluate the different variant alternative concept. I have to provide a variant management solution for it. And the variability needs to be tackled in a certain way. Later, if the offer team comes and tells me, we need to be able that what we offer to the customer, it's in line with the product line, and we don't offer feature that cannot be realized, there is already another use case, another type of variability that you need to consider. So it's important that we have clearly in mind which phase of the PDP, product development plan, and product development process we are supporting, okay? It's another challenge. It is not easy because each phase has its own peculiarities. Another aspect, we are strong supporter. I also, because of my background, I also MBSE expert. I really believe that you will see in the next slide is not just PLE, it's MB-PLE. So it's the model-based approach that it's key, it's fundamental to boost the product line one and vice versa. So when you apply any system engineering approach, but of course model-based, even better, we have to consider different viewpoints, so different level of abstractions. This it means that we will have to tackle the variability at the mission level of a program, at the operational, the different operations that you have. Imagine the cabin. The cabin has different operations offered by the crew. We need to consider the variability at that level. Imagine the variability at the function, the different functions that we have, the variability at the logical and technical level. So it's really important that the variability is not just at one specific abstraction, but at multiple levels of abstraction. And this, of course, is a challenge, especially when you want to develop a methodology consistent across the layers. Last but not least is the complexity of our product itself. So we produce, if we focus on the aircraft, but we could do the same for industrial systems. We have a hierarchy, a breakdown, a system hierarchy level, and we have variability at each level. So understanding how the variability cascading from one level to another, how we can support its formalization and its implementation, this is, of course, also another big challenge. And then there is the biggest challenge of all of them, that all this activity, I don't do it with robots, we don't do it with machines or with tools, we do it with people. And this is the biggest challenge. No? So explaining the concept, make sure they understand, make sure they have the same view, we are on the same page, and then they apply that in the same way, in the right way, at least in the way we propose. So this is, of course, especially for a program like DDMS, that is a global program. We have a global mandate. We need to be sure that everybody apply the methodology, I would not say in the same way, but under the same principle, under the same framework. So these are for sure the biggest challenges we have.
Okay, thank you, Marco. And my next question is about actually the methodology part. I know the methodology you use at Airbus to achieve the variant management is called MB-PLE. Actually, it's model-based product engineering. Could you please share with us more information about it?
Of course. So I have first a video, okay? So I will show you a short videos that we usually use at Airbus for all those people that don't know anything about product line, reuse of assets. And this is the entry point to the topic. I would say even for children, because it's really easy. So and that's what we use to, let's say, promote and to as a first entry point to the topic, okay? So I will do the same with you. So I will show the video, and then I will talk a bit about that, okay? So if it's okay for you. So, I will comment the video after. So I think this was, as you could see, even if when you think about Airbus now, you may think about a company that is, develop complex systems, and you can start to think about aerodynamics, simulation models, and all these type of things. In the end, we also have to communicate with people that are in the sales or in the human resource, finance, procurement. So it means that we need to find a way, a common understanding of the topic. And that's why I use also this type of simple example. No? So you see the Disney example to give at least the idea and of what we of reuse something, okay, of reuse something, but not having the final product as a variant. Just that concept, I think everybody can understand. What is a bit more difficult is the concept of reusing assets to produce the variant. So this is a bit more difficult than understanding just the concept of reusing a component. So answering your question, MB-PLE means model-based product line engineering. So basically, I take the definition from, I think it was from Matthew Hause and from Ferrogalini Schale, 2014, I guess, started to talk about this MB-PLE. The idea behind is that we believe in Airbus that since the two key pillars are the product line approach and the modeling simulation, these are two pillars of Airbus, we really believe that the combination of product line engineering and model-based system engineering can boost the both sides. So we can achieve better reuse of models, better reusability of models, better return on investment for when you do model-based system engineering. At the same time, we can achieve a better product line engineering if we do it in a model-based way. So that's basically one of the key belief of the team and of what we believe within DDMS. Okay. And yes, so this is basically what I can say about MB-PLE.
Okay, thanks, Marco. So I would say it's a very interesting, very good video.
Maybe what I can add that would be useful a bit to understand the usage of MB-PLE along the development. So since we talked in the beginning about the development, I said that product line engineering can be applied in different phases, in different ways. Maybe I can give just a rough idea about that, what I mean with that, if it's okay for you.
Yeah, sure.
So if you remember, this was what I showed in the beginning. There's a new product development plan. And now I would like to show you what we mean with MB-PLE can support different use cases, different phases of the PDP, to say better. So imagine that this is the development, the complete development, of course, really simplified, of an aircraft, okay? So you have now the key phases, and you want to do it, as I said, with the out of cycle and the on cycle with a product line approach. First step is, of course, we are just focused on the development, so we are not touching here now the product line scoping, the marketing part. So let's say that all this information comes to us from the strategy and market department, all the analysis that have been done. And then according to these variability inputs that we get, these market segments and so on, let's call it product line scope. Then we define and formalize optimal level of variability for the Airbus business families. So it means that all this the business system of Airbus. And we do it with a feature model and with the creation of 150% assets. Now, these assets probably at this stage will not be so detailed, but still we apply from the beginning. The idea is to apply the feature models to formalize the variability and the under 50% assets in order to implement it. So then we have the variability formalized. So we have, let's say, it's clear the mission of our product with the high-level variability. And then we go to the second phase. Second phase that probably we will have alternative concepts, and that we want to, of course, keep. Sometimes we will kill some concept along the way. But even when we kill and select one concept instead of another, we have to keep this concept for a long time. Imagine that the new development now of the hydrogen zero emission program is target for 2035, but we already started the feasibility phase. So it means that probably for the next 2, 3, 4 years, we will keep this alternative with us. So we need to have a way to manage this variability, even if it's temporary. That's why we have also a way, we have to ensure that MB-PLE support the management, definition and management of trade-off, for example, of the variability for trade-off. Another, after, let's say, you have selected the concept is clear which concept you want to have for the product lines. Then we start detailing our solution. So we start to develop, reuse existing assets that were already developed before, that we think have a good degree of can be reused. Plus, we develop new one to implement the variability that we have defined. Okay, so this is really important step. And finally, we will have step 4, last step of the auto cycle. We will have a baseline of our product line. We will have a formalization of the variability of the product line at that moment, and also the related under 50% assets. So this is the end of the auto cycle phase. We are ready to freeze the solution to go to the offer. So we are ready to freeze the product line part to go to the offer phase. So now we will go into the offer. So we are now offering our solution. We start to offer because the offer process also is quite complicated. So the first step is we offer what we have, and we go into the end cycle. So we need to be sure that we offer something that can be realized and that is not conflicting with the original variability defined. So that's why we have an offer that it should be based on the product line and under 50% assets, so that we develop out of cycle. We need to understand, because customer can come up with new features, new things that we didn't foresee. So in case, we need to understand the impact of these features. We need to prove since we have a product line, as I told in the beginning, we can better assess this cost through traceability, change impact analysis, and we will see what means a new feature in the architecture, which change it means, and change it means cost. So for the customer, will be clear, okay, does it make sense to have this change, this additional cost, or I can fulfill my needs in another way? So we'll be able to better influence customer also in a positive way to make the right choice that brings an added value to them. And of course, end up in a selection negotiation of option and features. It's more in later phase, so it will be clear also which additional features and can be implemented. Sometimes can happen that some of the features are just implemented for a specific program, for a specific customer. That's fully okay, so it can happen. But of course, it's always good to think, and if what we develop for one single program can be then reused, brought back to the product line, and extend the basis of our product line, maybe with an evolution of the product line. So this consideration can be done. And finally, we are able to derive the product line assets, so within a product line engineering approach, and define the first variant that we call head-of version. So from the product line, the head-of version is basically the first configuration that we offer to an airline. So it's, let's say, Emirates, KLM, Lufthansa will have the first configuration of our product line. And then they can still make changes and add options. So of course, this is agreed with us. And so we have, let's say, a second level of configuration that in order to add the additional extension of variability so that we can deliver at the end a final configuration. And here we can even perform additional customization if it's really needed. But of course, it should not be for those parts of the aircraft that have an high impact on the functionality, on the operation, because otherwise we need to rechange our concept. We can create big problem and risk on our concept. So it's good that this customization that is done on purpose for the airline, it's done for things that don't have a big impact on the architecture. So this is just for you to make you understand that we, on these phases, we have product line engineering that is supporting. So it's embedded transversally across all these phases from the beginning of the feasibility to phase to the delivery of the aircraft. So we will deal with product line engineering. So as you can see, it's a really important process, really important concept within Airbus, or at least it's becoming a very important concept within Airbus. So.
Yeah. Okay, thank you, Marco. So thank you for sharing with us this information, also all about these cycles. And another question is about Airbus is such a big organization, yeah, and you, as you mentioned, you have different dimensions. You have products with multiple systems. You have your services, industry systems, yeah. So I can imagine that lots of people and departments are getting involved, yeah, in variant management. So how to adopt MB-PLE in such a big organization at Airbus?
So I already have the slide for it because we prepare. It's not because I can read his mind or forecast the future. So it's important that we take the topic not just from a tool perspective, not just from a single department, but we have a common centrally led initiative. Okay, and that's why we have DDMS, the program, transformation program. So within DDMS, we have a group of people that I have really the pleasure to lead that works on the MB-PLE topic. So what we did from the beginning is that we define a framework. So first thing, we define a framework. We said, okay, we develop a capability for the organization that is a method, a tools, a process, and we need to have a framework to show what we develop, which piece, which bricks we develop for the capabilities, to which part belongs, to which it's a more process, as I showed you before, it's more a handbook and a method, it's more tools, data model, ontology, information model, and so on. That's why we developed this framework. So this for us was really important to have, for example, under the process, we explain how do we apply the standards related to product line, either the ISO 2650 or the new ISO 26580, and we show how MB-PLE is bringing an added value to the Airbus business processes, which is the link with the system engineering processes. So it's really important to take care about the processes, okay? Then the methods, we always distinguish between tools and methods. So we have in Airbus the definition that methods is always tool agnostic. Then we have the handbook that is the implementation of the method within a tool. So are the guidelines of how to use the method that is tool agnostic with a specific tool or tool set. Then we have the information model that are basically the data model that we use to have interoperability between different concepts and to be sure that if there's somebody working on configuration management, we know exactly which elements we can link. So the features, the assets, or same things for MBSE and so on. It's good to have an information model to really talk the same language, to be able to speak the same language. And the tools, of course. We have a tool chain that help us to implement the method and the tools. And then I have another category, environment. Environment is a broader category, but it's really important. In the environment, I have all that is not the process, method, handbooks, information model, and tool. For example, knowledge management. So it's important that all that we produce is shared publicly and transparently across the organization. If I don't develop something, I keep for myself. No, everything is shared, and we have a page, a MB-PLE page that is public to everybody, with all the proof of concept, with all the method, the handbooks, and so on. Then in the environment, we have the proof of concept. So we have a community of practice of people that work with MB-PLE that develop proof of concept for different sub-capabilities that we need to develop. And we test them with key users. So we have this community, okay? And this is part of the environment. So, and of course, I didn't mention, but it's clear, in order to do that, you need to have a clear mission and vision. You need to know which is the mission of this team. And for us, it's really to provide, in an incremental way, MB-PLE capabilities can be addressed the different challenge that Airbus has in the development of product line and the management of variability. And I say incremental way because, of course, DDMS, the program, is targeted to 2025. But we cannot tell to the users, no, we'll produce for you something in 2025. No, we need to prove the values already now, okay? That's what we try to do. And the vision is really in the end that we would like to go in the beginning, I show you this, we have to go from product to product line oriented. This means everything and anything. So everything and nothing, because if you don't have the right mechanism, the right process, the right tool to do that, then it's just an organizational change, it's just an attempt. And I have participated in the past in several also failed attempts with the previous companies to move from a project to product-oriented or platform-oriented organization. So that's why we really need to establish this culture, this mindset of product line engineering, of reusability across the asset and so on. So this is a bit how we think we can implement it. Then, as I mentioned before, we have the proof of concepts. So it means that I'm not seated in the ivory tower of method development. And then I go to the people and say, oh, this is the methodology you have to apply. No, this will never work, okay? So we need to involve stakeholders and key users from the beginning, even in the method development. So that's why we have several proof of concept that span from system, product, industrial, and so on. Also with different scope. Not all the proof of concept do the same. So each proof of concept has its own scope. For example, we tested the application of MBSE for the landing gear, the landing system, more the aspect of integration of lavatory within the cabin, always with variability in integration, or the aspect of dealing with multiple configuration of partial configuration, if you are familiar with the prevariance terminology. So how do we deal with that? POPs concerning the wings, so how we can produce different variants of the wings depending on the different programs requirements with a model-based approach. But also we don't have to forget the industrial part, because we are pushing a lot on the application of MB-PLE and MBSE in the industrial world. So that's why we have also industrial example, like we try to apply MB-PLE for the variability of the automatic drilling unit. You need to drill so different holes within the aircraft, or trolleys that are used for the non-flying goods for manufacturing purposes, and also more process and direction processes and systems that we need to install pylon and engine within aircraft. So these are just some of the proof of concept that we run. As what I show you here comes from, as I said before, knowledge management, transparency. So we have a page in our MB-PLE page, and everybody in Airbus can access. For example, if we go to the cabin lavatory module, so you will have everything is documented, the POC. So what are the people involved, video, presentation, examples. So we really want to document what we do, also that everybody can benefit from it. So the idea is really sharing and involving experts in the development of the methods. So yeah, so this was more or less my answer.
Yeah, thanks so much, Marco. I think the idea of documenting everything, and also have this, having this different POCs to prove whether the methodology is capable of tackling the PLE challenges at Airbus can really benefit our audiences. Thanks so much. So my next question is actually about the combination part. Yeah, it's about the combination of MBSE and PLE. So what are the important things to do to implement the MBSE in PLE? So which actions did you take?
So we are a big company. We don't work alone. Okay, so I don't develop things in silo or standalone way. So we have a big team working, and a very good, excellent team working on the MBSE development. Okay, so they do the same. They develop a framework to apply MBSE, and of course I have a strong interface with them. So I need to be sure that what we produced in terms of capability, it's in line and integrated with MBSE. So, and this is key for MB-PLE, okay, because it's probably so the first type of assets that we want to integrate are the models, okay, the system and models in particular. So that's why one of the key steps for us was really to integrate the MBSE approach and framework at Airbus that it's called MOFLT, Mission, Operation, Functional, Logical, and Technical, with the product line engineering part. Okay, so and we have a simplification of it. Of course, we call it the method snake, and for MB-PLE for MOFLT. So first steps, it's for like any initial approach that has a product line engineering in itself. We start with define feature model and feature configuration. Okay, so we define the feature models, the features, and the feature configuration up front. Then we go into the operational layer, and we try to analyze the impact of the features of the variability within the operational layer. We identify, because our methodology doesn't create variation points. So now I start to get more into the detailed terminology, but for operation element, but does that for solution. So we are here more on the problem space. We do it more for the solution space. So after we identify variability in the operation analysis, then we start defining the variability, because we are going to the solution according to the features for the operational layer, for the functional architecture, for the functional layer. Okay, so the functional variability according to the original feature, always the same type of feature that we identify in the beginning. Then we assess the variability in the logical architecture, so functional allocated to logical, as we will see later, to logical blocks and logical components. And since the variability, the functional level, it's more a grouping of the functions, we don't have variation point for the logical component, but the variation point are created at the functional level. And then finally, we have the technical level, that it's also, we define variability for technical level, because it's basically the realization of the logical component into physical and technical solutions, specific solutions. After we do this, let's say for the product line, for our under 50%, then we can visualize the configuration and perform the model transformation triggered by the feature selections. And we can, let's say, create from the under 50% with the support of the features, the 100%. Now, all this approach I show to you in a sequential way, but is never sequential, is always iterative. Okay, so it means that we can define some feature, analyze the operational layer, then we can go back to the features because we identify additional variability that we didn't record. Same thing when you go to the functional and so on. So one important thing is that when we develop this framework integrated with MBSE, we need to take in consideration different products. So as I said, we develop the framework for program and to apply for cabin solutions or for landing gear solution, but then also for industrial system. And the approach may have some slightly differences. That's why it's important that we take into account the needs of the user and we are able to tailor the methodology. Okay. Now maybe a practical example, if I have some time, so you can see more something practical what I just showed you.
Yes, please.
So if okay with you. So let me start with this. So first I use an example that is the e-taxi. E-taxi is basically the electrical taxi of the aircraft. There is a taxi phase, no? Basically when the aircraft is right at the airport, and then after landed, so you need to move the aircraft, and same things when you start before taking off. So this type of taxi functionality operation can be done in a different way. So now you will see here a profile. This is not pure variance. So we started to define the variability for simplicity in our own plugin that is called SysFM, System Feature Modeling, because users are really familiar with Cameo. So they actually prefer to, instead of defining features in Xmind or mind map, they really like to do it directly in Cameo and benefit from the model-based functionalities. So the first step is really to define things, the features with drag and drop functionality. We develop a profile that really is one-to-one, looks like pure variance in terms of notation. So just 1 second. So here we have different variability for the e-taxi. So we may have different type of pushback, can be done in an autonomous way or externally triggered. So we have different type of wheel task, and basically we have also type of monitoring system that we may have to monitor that the automatic pushback is done in the right way without under safety constraints and so on. So first we define the feature model, then we select the configurations here in Cameo. So we select for each features, for each configuration, the feature that we want to have. And then after users have discussed the features, and we import them in pure variance. So we have created an import-export functionality that import features from Cameo into pure variance, and we have now the feature in pure variance with the different configurations. And this is the first step. So user can start directly with pure variance, so they don't have to go through SysFM. And many users want to use it because it's much simpler, especially if you want to collect inputs from people that are not familiar to modeling, to software. So the profile can be learned really in 30 minutes, 40 minutes, how to define features in this way. Pure variance is much more elaborated, but still we need pure variance. There are teams that work directly with pure variance, don't pass through this step, okay? So after we have defined the features, then we speed up a bit. We go to the next steps. If you remember the snake, the next steps is defining the operation. So we define the different operations. For example, we have different phases of the aircraft. So we can see here now the example, we have different phases. So we have the pushback phase. So we can do the pushback in one way with some operation or with other operations. So we model really the variability at this level for the operation. And it's basically show that some phases are the same, some operation tasks are the same, some behavior are the same, some of them are variant, okay? So we really are building now the variation within the operational phase. Here we have more the detail with the swim lanes and the different behavior and task of the operation. So I will not go into the details because of time, but let's say after we have identified the variability of the operation, we go into the function architecture. So here you may see that, so we start to build the place where we start to build variation points with our features. So we have now our behavior that we relate to the functional block. So if we go now to so here we have our function architecture of the function that implement the taxi. And we can see already the blue dots. We build the variation points on the functional blocks, and we have functions that are common, and some of them that are variable. Those that have the variation points of the block. And here, of course, the IBD, the internal block diagram, that show the under 50% view with the several interfaces. This, of course, later will be filtered depending on the feature that you select. So then we have after we have defined the functional level, we, as you can see, this is really a model-based system engineering approach that we use. So we have defined the logical components with allocated function, and we have allocated function to the different components. We don't define variation point for the logical component since the variation is driven by the function. So we mainly made the variation point of the functions here, and we have the different functions allocated in the logical components. And then last step is the technical one, where we build and define variation point for the technical one. So we have now the technical, of course, is linked to the logical, is realizing a logical component. And here we have again more variability variation points. You can see the blue dots on the technical block. And we have, of course, the technical architecture with the different interfaces. So that's more it's the closest to the physical view. And we have here also variability driven by performances, variability driven by structural interfaces, and something that probably you don't have the functional or the logical level. And after we have built the variability within our under 50% architecture, then the last steps, we have to perform the transformation, so feature selection and transformation. So that's why we have now select pure variants. We select the different configurations. And it's interesting here that we see that the variability is defined consistently. So not just defined for one layer, but it's defined consistently across operational, functional, logical, and technical. So if you make a selection of feature, you will see the impact at all the level of abstraction. So that's what I said in the beginning. It's important that we consider also different level of abstraction. We don't just focus on the physical layer, on the logical layer, but it's important that because in the end, we need to be able to transform and instantiate the entire under 50% model, not just one part of it. And here we can see the impact on the feature selection. And of course, then the model transformation, well-known model transformation that will transform into the 100%, the under 50%. And here we see that now the features that are not, of course, then the layout can be reorganized, but it's just for the demonstration. So this, of course, I cannot go into, it will take, let's say, 1 hour only to explain the example, but just to give you an idea. For me, it's important to give you an idea that it's really not just a tool topic. It's really not just defining, having a small POC and defining the variability on one layer. No, we are really talking about applying a methodology that is consistent, that has variability for a big scope, such the development of an aircraft and the related systems.
Okay, thanks, Marco. So yeah, we have talked about what do you have now for variant management at Airbus. So what are the plans at Airbus in the future for variant management or for MB-PLE?
So, let me say that the following. First, we need to, I think I can stop sharing because this was my last slides. So just 1 second, I have a small technical problem. So we stop sharing. Okay. So yeah, so we're talking about you said the next steps, right?
Yes. Next steps.
Okay. So let me. So basically, first is that the vision of Airbus is to bring the MB-PLE approach and the digital continuity from features to the manufacturing part. So it means that we want to bridge the gap from the feature that we offer to the customer up to the realization of the product with the manufacturing team. So it means that having this type of digital continuity and traceability from features to the final physical components and not only. So this is the idea is really to have a solution that enables digital continuity. This you cannot do it with one tool. Of course, it needs to be implemented also with a tool chain, okay, that support that. So then the next thing that we need to continue is incremental development. So we always need to deal with teams that want to use a part of your solution now and the long-term view. So we need to have this type of incremental development of the capability. So it's important that we have business release of the capability each 3-4 months, so that user can already test it and apply it, okay? And then another thing that is really important is we are working a lot on that. We are partner of Dassault Systems, and we are performing an integration, so an exploration of Dassault Systems. And at the moment, one thing will be how we can combine, for example, pure variants and Dassault System solutions, not just Cameo. And this is also a big topic I'm working in, and challenging topic, I would say, but it's really important for us. And then in the end, why we do that? We do that because the ultimate scope is that the new generation of products, so the zero emission, the e-action, FCAS, that's the future combat system, air combat system, also not just commercial, but also defense and helicopter, can use the solution in the program. So we really do this not just to test a proof of concept, to explore it. We would like that the solution go to a level of industrialization within the company that can be used across within the program. Okay. And yeah, these I would say are the key steps. And of course, I would try to be now, due to time, more involved also international group, product line engineering groups. I'm searching for synergy also with other companies, because for me, we need to bring the topic also MB-PLE. It's more than Airbus, and I really would like to also do a bit more externally. So that's what I would try to do. But of course, the time is always running, and it's not always easy to focus on the aspect, no? Like a standard development or so working group and so on.
Okay. Thanks, Marco. So my next question is actually about pure variance, the tool we provide. So what do you think of pure variance, and how was the experience with using pure variance?
So I can say that today, for me, is probably the most mature solution in the market. And I have worked with several solutions, okay, in the past 10 years. And for me, it's the most mature solution, okay? Now, this doesn't mean that it's a perfect solution. And there's also some limitations, okay? And for example, the fact that it's Eclipse-based is a limitation itself, certain aspect. So, and of course, but even so, users in the beginning maybe have some problem because it's a bit complicated, but then when they know how to use it, also with our support, they really like it. So that's why it's definitely a positive feedback. Now, for us, the discussion is more than pure variant. Since we have other tools, I talk about digital continuity, so we have also to think about how to use pure variance in a bigger context, and we are working on that, okay? What I want to say is that it's more a message, a statement. We should also bring a bit the topic of PLE out of the tool only, okay? Today, when I speak to somebody about product line engineering, MB-PLE, they always tell me, which tool do you use? But for me, it's a relevant question, but we should also try to bring the concept more, okay, on methodology concept level, like, okay, is always the under 50% approach the right approach? When, in which case is not? How we can combine SysML with a feature-based approach? Detaching a bit the topic from the tool, okay? So, and this is nothing against pure variance, just that I think we should bring the discussion also beyond the tool. And but in general, I also work almost 1 year with Young and with the Pure System team and the Pure Consult team, and it was really a very good experience. Very knowledgeable people, so definitely a positive experience.
Yeah, thanks so much, Marco. Actually, we are also pretty keen on to, improving the PLE and also integrated with other tools, other methodology. Thanks. So here is the last question from my side. I would say, are there any hints or suggestions you can give to the audiences? For example, what they should keep in mind if they want to introduce PLE into their own company, or what they should do or what they should avoid?
So, well, difficult question, but let's say, first things I would say is that simplify the concept. So you saw in the beginning a video of Disney, and then we need to use a simplified terminology, okay? So we cannot expect that everybody understand variation point, variant, feature dependency, constraint. No, we need to bring the discussion on a level that everybody can understand, and then tailor it depending on the audience you have in front of you. So this is really important, okay? Not because it's Airbus, people automatically understand. No, it's not the case. Simplify. So then we need to show the business value of it within the organization. This is also for MBSE, the same topic. We need to show where exactly is bringing the value, added value to the business, and not just remain, decrease cost. No, we need to really prove where is the added value. Okay, otherwise they will not use it. Okay, so it will not change what they already have because that is a trendy thing. No, it's not the case. Then I would say that another suggestion is that you have to, as you see, have a clear vision, a clear mission. So you need to know where you want to go. You cannot just, let's have a look at your variants, let's see what the tool can do. For me, this is really a limited view. You should really have on board expert, consultant if it's necessary, and not try to reinvent the wheel, okay? So it means that not, I have now this new way of defining the approach that is better than feature-based. No, let's try to focus on standard. Let's try to listen to experts on the topic and not try to invent in each team in the organization a new way of doing it. You need to involve the key stakeholders, because as you saw, it's important that it's not just done by a single team. Or we need to involve the key stakeholders in the process and make them participant. This is really key also because we benefit from that, okay? So we understand what is important, what they accept, what they don't accept, and we can benefit from their knowledge. And then for me, you need to create a hype. So it means that you need to be sure that, so we are now in the social network area, so we need to be sure that we have this hashtag MB-PLE and people know what is it. So people talk about that. Some people will not know what it is. Some people will understand just a little what it is. We have, it's the things about Disney. Maybe they can just refer to it in this way. It's okay. Create a hype. Make people talk about the topic in the organization, okay? So this is for me really important. It's really a key strategy that we are also taking from other businesses, but it's really key. Then I would say don't think about to integrate all the assets or requirement test cases, software code, MBSE models, geometrical design, electrical design from the beginning, because this will never work, okay? So start with one or two assets type, so requirements, models, or requirements, source codes, and then step by step, you include the others. Of course, you need to have the vision of the asset that you want to include, but try to work with this incremental approach, okay? And then finally, use a framework, okay? So not important which framework, but define a framework for your organization, to apply, define that you want to have a method, a tool, a process, perfect, okay? You have people working on process, method, and tool. Define that you want to have a team for knowledge management, you want to focus on the information model part. So have a framework that structures the work, and please don't just focus on the tool. Don't reduce all the discussion about, maybe it's not nothing against prevalence. We need tools. We need good tools, integrated tools, but this is not enough. Please don't focus the discussion and don't bring the discussion just on the tool. So this is some of the many recommendations, but this is really from my personal experience, and I hope it helps.
Yeah. Okay, thanks, Marco. I think we are reaching the end of this webinar, but maybe at least we can pick up one question from our audiences. So I think maybe we can answer the one, do you manage variability in requirements? And with which tool in that case?
Yes, so this is a very good question. At the moment, we use DOORS 9. And we are working this year on having also a model-based solution for requirement management. And for the future, is still in discussion. Probably we will have DOORS and the Dassault system application, so TRM, traceability requirement management. And there will be some program that will continue to use DOORS. But actually, the idea, the strategy is to go to decommission step-by-step DOORS and go into the TRM when the solution is mature.
Okay, so thanks so much, Marco. I think that's all for this webinar, for this interview.
I see there is another question. Let me make it quick. I think I can.
Yes, if you can quick answer them. Otherwise, we are reaching the end. Yeah.
Yes. Do you link a bill of material items to your models? This depends on really on the. We have a team that is working on the 3D design, and and basically they are also responsible for the bill of material. So we are now in the concept phase. So we are thinking how we can link not maybe the feature directly only, also we on the model itself, so the architecture part, the last layer with the bill of material. And we have an additional space that we call internally. It's a space that where we have the Archi model, so we call it. So it's really a model that we use for interfacing the MBSE models, the system models with the bill of material. we are exploring now how to do it with the features also, and for the variable modeling part. We, as I told you, we are following an incremental approach. So this is in the roadmap, but it's coming more as a to-do. Okay.
Okay. So I think we have already run this webinar.
Yes, sorry for that.
Okay, so that's all, and yeah, thanks so much, Marco, and yeah, I really thank you again, for joining this webinar, and I wish you a lot of success this year.
For the audience, if you have any questions, you can reach me per email. So my email is very easy. So my name dot my surname and airbus.com. So easy. Okay.
Yes. So yes, if you don't know Marco's email, maybe you can also contact us. We can provide Marco's emails to you. Good. Then thanks so much, Marco, again, and thanks so much our audiences. And I wish you next evening and next day. See you. Bye.
Bye bye.